In this video, I'm going to talk about how to solve two-step equations. For today, there are two important questions. First, what does a two-step equation represent? And second, how can we solve two-step equations? First, how can we visualize a two-step equation? What would that look like? So see this equation, 5x plus 1 equals 16. We can make a picture to represent this. We'll have 5x, so that's 5 x's, plus 1 on one side, and then 16 on the other side. And you notice that these two sides are equal, so this scale here is balanced. One's not greater than the other. So we want to know what x itself is, what 1x is equal to. So we want to get 1x alone on this scale. So first we want to get rid of this plus 1 that's here with the x term. So we can subtract 1 and it'll go away. And if we subtract 1, we'll have to subtract 1 from the other side of the equation as well. So now we have 5x equals 15. But remember, we want to know what 1x is equal to. So those 5x's, we want to split them up. We want to divide them apart. So we'll divide 5x by 5. And if we do that, then we'll have to do the same thing to the other side and divide 15 by 5. So we can represent that visually with these lines here, and then we can see that for each x, it corresponds to 3 on the other side. So x is equal to 3. Remember that when we solve equations, we want to do opposite operations. So if you see addition, you'll subtract, and if you see subtraction, you'll add. If you see multiplication, you'll divide, and if you see division, you'll multiply. Those inverse operations are what will help us undo everything and isolate the variable. So, if a two-step equation has two operations, how do you know which to do first? You can think of this as working opposite from the typical order of operations. Parentheses, exponents, multiply and divide, add and subtract. We're going to reverse that. First, we'll do the addition and subtraction, then the multiplication and division. So let's see an example without a picture. We'll just follow these two steps we have here. So we have 3b minus 2 equals 4. So first we're going to deal with this subtraction, this minus 2. The opposite of minus 2 is plus 2. So we'll add 2 to both sides of the equation to keep it balanced. Negative 2 plus 2 is 0, so that'll just disappear. And we're left with 3b on that side and 4 plus 2, or 6, on the other side. So we have 3b equals 6. In the next step, we have 3b, which is 3 times b, so we're going to use division to get rid of that. So we'll divide both sides by 3. 3 divided by 3 becomes 1, so 1b we can just write as b, and 6 divided by 3 is 2. So we have b equals 2. In the next example, we have negative 2p plus 15 equals 51. So again, we'll start with this adding and subtracting. So we have plus 15, and we'll undo that by subtracting 15 from both sides. From there, we have negative 2p equals 36. Then to get rid of this multiplication of negative 2, we'll divide both sides by negative 2, which will give us p equals negative 18. In this last example, we have b divided by 5 plus negative 36 equals negative 28. So again, first we'll deal with the addition and subtraction. So the opposite of negative 36 here is plus 36 to both sides. From there we have b over 5 equals 8. Now this b over 5 is b divided by 5. So the inverse operation we want to use is multiplication. We'll multiply both sides by 5. b divided by 5 times 5 is just b, because those operations are inverses. And 8 times 5 is 40, giving us b equals 40. So now to wrap up, let's go back to those two questions from the beginning. First, what does a two-step equation represent? You can visualize this by thinking about a balanced scale. Like we saw in the beginning of the video, we've got these two expressions, an x term plus a constant, and another constant, and they're equal, but we want to know what x itself equals. That's what a two-step equation represents. Second, how do we solve two-step equations? First, you want to deal with any addition or subtraction that you have. Second, deal with multiplication and division. And your goal, of course, is to isolate the variable term using inverse operations. That's it for today. I hope you enjoyed. I hope you learned something. Thanks for watching and have a great day.